Hello everyone, today we are going to discuss about how Traceroute works. So irrespective of the teams, whether it is a server team, database, network, whoever, we usually use the command, if you see here the traceroute and the destination IP, generally to see the path or the hop count in between from the source to destination. So we'll get the output. So how many hops are there in between from source to destination? So how does it work? What is the mechanism behind this? So first let's understand this topology here. So this is the R1 which has the IP address of 10.1.1.1, R2 which has 10.1.1.2 and the other end IP is 20.20.1.2, R3 20.21.3 IP and 61.1.1, R4 60.1.1.1.2. So let's see, we are going to do a trace route first from R1 to R2 and then from R1 to R4. So when we do from R1 to R4, what happens in between and how does it show us the output? So what actually happens in between, what packets will exchange? Okay, while explaining, please focus on this yellow colored numbering. You see here TTL value, you see the yellow number 1, 2, 3, 4, 5, 6 and so on. So please, this is the serial number which I mentioned just to have the focus what would be the next step. Okay. So when I am doing the trace route from R1 to R2 or from R1 to R4, okay, a UDP packet will be generated initially. So a UDP packet contains, the source will be the random port and we deliberately mention the destination port as 33434, 33434, and we have the, initially we will be having what, TTL value of 1 and with the source random port and the destination port 33434 and the TTL value 1, this UDP packet will be sent from R1 to R2. Remember, the UDP packet will be sent from R1 to R2 and I am doing the trace route to R4. So what R2 will do, R2 has to send this UDP packet further from R2 to R3, right? But what happens to send that, it has to reduce the TTL value, but the TTL value reached here is TTL value of 1. So when it reduces to a number 0, it becomes a 0. When it reduces furthermore, it becomes the TTL value 0. So this R2 will send a ICMP packet. If you see the red dashed line here, so R2 will send a ICMP packet which contains TTL exceeded message. So this, remember, when we are sending a TTL value, it will be sent in a UDP packet. When we are doing the trace route, initial packets will be sent as a UDP packet. The return packets will be ICMP packet, which will be a TTL exceeded message. So when R1 receives this ICMP packet which contains TTL exceeded message, what it will do? Step number 3 here. So R1 receives TTL exceeded message and now it increases the TTL value to 2. Initially it is 1. Now it increases the TTL value to 2 and sends again to R2. So TTL value increases to 2 and sends again to R2. R2, now it has the TTL value of 2. So to further send this UDP packet to R3, it can reduce, so 2 becomes 1. So you can see here TTL value will be 1. And the UDP packet is sent to R3. Okay, and R3 to send the same UDP packet to R4, it has to reduce one more number, but here the TTL value is 1 and if it reduces furthermore the TTL value will be 0, so it can't send to R4. So what R3 will do? R3 will again, it initiates an ICMP packet with the TTL exceeded message. You can see here red dashed line. R3 will send ICMP packet with the TTL exceeded message to R2, and R2 will further send the same ICMP packet to R1. And R1, the source, the initiator, it receives this ICMP packet with the TTL exceeded message. It now further increases the TTL value to 3. Initially it was 2, now it increases the TTL value to 3 and sends again to R2. Now R1 sends to R2 with the TTL value of 3. UDP packet came here and it reduces one number to send to R3. So our TTL value will be 2, and that UDP packet reached here, and to further send the same UDP packet it has to reduce one more number. So TTL value 2 here, when it reached here the TTL value is 2, it reduces one more number and sends to R4. So TTL value will be 1 here and sends to R4. So finally when it reached to R4, the TTL value is 1, but it can't send further to any other router. If let's say no other routers are placed in this diagram, but let's say we have one more router R5, it can't send, because to send it has to reduce one more number, the TTL value will become 0, so the packet will be dropped. Again it initiates TTL exceeded message. So but what happens here? It reached the R4. When it reaches the R4, it immediately checks if there are any listeners for the UDP port, which is 33434. If you remember here, initially the UDP packet is formed with the source with the random port and the destination port is 33434. We deliberately mentioned this destination port 33434 with the highest number, okay, with the higher UDP port number. So now when it reached here, when the target reached the R4, now it checks if there are any listeners for this UDP port, and there will be no user or application listening to that port. So the UDP has to discard this message. Now this UDP also sends an ICMP message to R1, but this time instead of TTL expiry it sends port unreachable message. So this R4 will initiates, if you see the blue dashed line, so this R4 sends ICMP packet to R1 with the port unreachable message. Okay, so this is the whole process of the traceroute. So when you see the traceroute output, have you ever observed, okay, when I have done the traceroute to 2021.2 from which is here, if you see here 2021.2, I am getting 2 milliseconds, 2 milliseconds, 2 milliseconds, and the next stop is showing 10.10.1.2. This is 10.1.1.2. That's true. R1 is 10.1.1.1, R2 is 10.1.1.2. But why I am getting 2 milliseconds, 2 milliseconds, 2 milliseconds? What is happening? And that's the iterations. The first iteration, second iteration, third iteration. When R1 receives the ICMP packet of TTL value exceeded message from R2, then first entry will be noted. Okay. Again, R2 sends UDP packet to R2. R2 sends back ICMP packet with the same TTL exceeded message to R1. I'll explain a little bit more about these iterations. First iteration, second iteration, third iteration, why it happens. I'll explain a little bit more in my next video. Okay, but I'll give you a brief about why these 3 iterations are happening here. It is because to check the consistency of the path. So from the R1 to R2, it sends 3 iterations, and if you see the 3 iterations, in the 3 iterations the time is 2 milliseconds, 2 milliseconds, 2 milliseconds, and it is consistent. To reach from the source to destination, it takes 2 milliseconds, and if you observe any inconsistency, it might show 2 milliseconds here, 100 milliseconds here, 200 milliseconds here. What it means, there is an inconsistency in the path to reach from source to destination. Okay, It only shows how consistent the path is from the source to destination, and how these iterations will form I'll explain you more in my next video. I hope I have given you a clear detailed explanation on how Traceroute works. If you have any doubts, you can message me, you can comment me, or you can go through this video again. Thank you. Thank you for watching. Have a good day.